Hello everyone. Today we're going to be looking at FreeCAD. FreeCAD is a pretty powerful 3D modeling tool I've been using for a little while now. It's totally free, which is a huge draw, at least it was for me. Whether you're new to CAD, like I was, or if you're switching from another program which has decided to start charging you exorbitant amounts of money for their license, this video is going to give you a good idea of what FreeCAD has to offer, sort of in the most basic capacity, and get you started with modeling something today. So they offer it in Windows, Mac, and Linux on their website. Though if you're using a Mac, you might be more likely to be able to afford something like Fusion 360. For Linux people, I don't even know what you're doing. I guess more detail-oriented work than I am. But on Windows, once you get that downloaded, it's going to give you a .exe file, and you'll be able to open up to something that looks a little bit like this. Your taskbar, maybe again over here, but I've gone ahead and moved mine over to this side where I prefer it to rest. Um, First, I'll go ahead and give you just a quick tour of what it has to offer on this start page. It's going to give you a few options here for how you like to maneuver around the software. I've chosen Blender because I've used Blender a little bit before, but whatever you prefer is going to be offered there. It's going to have an option for you that works. Um, if you hover over it without clicking, it's going to show you how that navigation style works if you're not familiar with any of them, and then you can decide which one you want to learn. Now, what's really cool about FreeCAD is that it's really simple, despite how overwhelming it might look at first. On the right hand side here, like I said, I've moved my taskbar. Your taskbar is going to give you easy prompts based on what you have selected and what stage you are in the designing process. On the left side, you're going to have your model tree. This is a model that I've already made, but it's going to give you a good idea of what that looks like. You're going to have a body, you're going to have an origin about which your body is oriented, and then you'll have your sketch and your pad. The pad is going to be what you extrude from the sketch, and the sketch is going to be the two-dimensional drawing that we create that represents the three-dimensional object we want to build. Now at the top, you're going to have all your tools. We're not going to be using all these today. We'll just be using a few. We're going to start by clicking on parametric part. This is going to give us a blank slate to work with. And on the taskbar over here, you're going to see in helper tools the option to create a sketch. That's the one we're going to be using today. We'll create a sketch, and just for simplicity's sake, we'll use the XY plane. Now, when we use the XY plane, we're going to be looking down on what you can imagine as your desk, just like you're drawing on your desk. Once we finish our two-dimensional drawing, you'll be able to extrude that up into a three-dimensional object, just as though you were lifting that sheet of paper off the desk and building that object there in front of you. Up here, we're going to see some of our most important tools. These are the ones we use to create shapes. We're going to start today with just the rectangle. We'll click rectangle, and we're going to bind the first vertice to the origin by just clicking the origin, and you'll see that that vertice is now stuck against the origin. We'll choose 50 millimeters by typing just 50, clicking enter. Now we get to choose the other dimension. We'll choose 25 millimeters. Now we get a notification now that we are fully constrained, which is what we want. Fully constrained is just indicative that every bit of the rectangle is defined. When we chose 50 millimeters and 25 millimeters, we defined the length and the width of our rectangle. And these lines here indicate that the lines are going to be parallel to one another, these and these respectively. If this were deleted, this parallel function, then we're going to see that this is able to move, because then these lines are still remaining parallel, but this line is not constrained properly. So we can constrain that by clicking on that line and clicking on this line and clicking P. That's going to reinstate the parallel function. Now, this parallel function is this line and this line, which we created, the long edges of the rectangle. Previously, it was just constrained horizontally, so it was constrained relative to this red axis here. But this is just fine as well. We are still fully constrained. We can go ahead and click close. When we close it, we'll come back to this first screen we were on, but now we have our sketch in our 3D space. To make that object three-dimensional, we're going to click Pad. It's going to give us a 10 millimeter default, but we can change this to, let's just say 5. And if we right-click down here, it's going to update that view for us because we have Update View selected. For now, we're going to ignore these options here. Symmetric to plane can be useful, but what we want right now is, like I said, just to lift that three-dimensional object off the table that we've sketched it on. We'll click OK, and that's going to lock our three-dimensional object at 5 millimeters. We can always go ahead and change that by double-clicking Pad over here in our model tree, and we'll come right back to this page we just saw. As for our sketch lies within the Pad tree, or the Pad branch of the model tree, and we can still change these values. For instance, if we were to right-click on this value here, 25 millimeters, and change it to 50, we'll notice that it updates our sketch. But when we close our sketch, it also updates our pad. So these are still linked and still active parts of our design. These are something that is fluid, regardless of whether or not you have a three-dimensional object already made. So once we have this object here, let's just say we wanted to add some, let's add some holes to this top face. So we'll click on this face, and we'll create a sketch. It's going to give us the top view, and we want these holes to be relative to these other edges here. But you'll notice that they don't give us the option to click on them the same way we can click on these origin lines, these axes. So in order to make these something we can interact with in this sketch, because it is a separate sketch, we're going to click Create External Geometry. We'll click on this line and this line. It's going to give us these purple lines, which are now something that we can interact with in this sketch. We're going to click the circle, and we'll make 1, 2 circles. Now, it doesn't matter if these are different sizes right now. We'll get to that in just a moment. We're going to start by locking these in space relative to these lines, like I just said. Now, what we'll start with, though, is creating a center line here that we can set them symmetrical to on either side of it. So we're going to toggle from construction geometry, which is what we've been using for these circles. That's going to create actual 3D model effect. We're going to click this over, and now we're on to non-constructive geometry. So we can click line, and we can attach the first vertice to the top line and the second to the bottom axes, and it's parallel, but it is locked to this here. And we can also see that by clicking here and doing dimension, it is 25 millimeters. So it's snapped to the center of the line. But if it were not constrained there, we could constrain it by using the same one that we used to set the size of the rectangle, which was the D key for dimension. We'll right-click to just cancel that operation since it's already constrained. But these circles are still under constrained. We'd like these to be fully constrained. We're going to set them symmetrical to this center line. So we're going to click the center dot of either circle, holding shift the whole time, and then click the center line here. We'll press S. It's going to set them symmetrical on either side. So wherever I move them, the other one will follow relative to the center line. I like these circles to be the same size. So I'll shift click both of them and click E for equal. Now you'll notice they're the same size. As I change one, the other one follows suit. But I want to define what size these circles are. So we'll click the circle itself, click D to set a diameter. D is still just for dimension, but in this case, being a circle, we're setting a diameter. We want this diameter to be 10 millimeters. So we'll type 10, click enter, and now our circles are locked both in dimension and symmetrical on either side of this line. The last thing for me to do is going to be define where I want these circles in space relative to the axes. I could choose a dimension function, clicking the center circle and the center line, clicking D here. It'll give me an option to choose how far I want this center from this line. I know that my rectangle along the long edge is 50 millimeters. I can use mathematical functions within the length and any other size option. So I can do even 50 divided by 2, and that's going to place the circle 25 millimeters from the center there. But of course, the 25 is going to set us all the way on this outside line. So rather than having this be 25, which we'll just put it on there, because we don't want just semicircles cut out of the edges, we can change this value to be, say, 15. Now these are set symmetrically in the left and right, and they're locked that way, but up and down they can still move. Let's just say that I want the center of the circle to be a certain distance from this line. We'll set it to be, again, 15. Whoops. You do have to click out of that before you set your numbers, otherwise it's going to use the number pad as the arrows. So we'll click D, click left click, and then we have the option to choose the length. So we'll choose 15 millimeters again, and these are offset from the center of this rectangle or this square here that's made now on either side. And if we wanted these to be centered completely and not just these dimensions from either of these references we have here, we could create a second center line across by using our non-constructive geometry again, across like that. And this is constrained and centered. And this is our ultimate center point of the rectangle. And rather than having these constraints, which we can delete by clicking on them and clicking the delete key, now these are able to move again, we can simply set these constrained to this line. And now it's able to move either way this way. And we can set these constrained to be a certain distance from the center line. And we'll make it the 25, golly, definitely want to remember to click outside of, click off of this before you set the length, otherwise you're going to get rotation you don't want. Set this to be 25 divided by 2. That's going to place them just there in the center, and everything is fully constrained. We can click close now, and we're brought back to the 3D model that we saw earlier. And to make these holes, rather than using the hole function, which is not going to make these always the same exact size as the circles we set, we'll use pocket. And as long as the length is deeper than the object, it'll set all the way through, or we can switch from dimension to just through all, and that's going to make this the most simple. So here we have our final object. This is the first object you've created now in FreeCAD. Please let me know if you have any questions or comments. Leave them down below. Don't forget to like and subscribe if you like the video, or leave hate comments if you dislike the video for whatever reason. I'd be interested to read those too. Otherwise, stay tuned for the next video. We'll be doing more in-depth stuff, more stuff. This is something a little bit more intricate, but we have other things as well in our recents that I'm sure you noticed before. This is something that I've been working on a little bit, and it's going to give function to an item that I use in my everyday life. So we'll talk about how you can use tools that you have at home to measure and to design something that's a little bit more functional than the rectangle with holes in it we just made a minute ago. Thank you for watching the end of the video. We'll see you next time.